Number 1. The Giant Leptocephalus. In 1884, a taxonomist named Theodore Gill submitted a paper to the Proceedings of the United States National Museum in which he made a simple observation about eels. The order Anguilliformes, he wrote, displayed an exceptional range of body sizes, and he warned against assuming that the species we had catalogued represented the upper limits of what the order could produce. At the time, nobody paid much attention. The largest confirmed eel was the European conger, topping out at roughly 3 meters. Big, certainly, but not the kind of animal that rewrites what you think is possible. Then, in 1930, a Danish oceanographer named Anton Brun was aboard the research vessel Dana, trawling through the deep waters of the South Atlantic near the Agulhas Current, a powerful western boundary current running along the southeastern coast of Africa, reaching depths exceeding 2,000 meters. When the nets came up, Brun found something that should not have existed, a Leptocephalus larva measuring 1.84 meters long. 6 feet of transparent, gelatinous, ribbon-shaped tissue with the unmistakable fang-like teeth of an eel in its juvenile stage. To understand why this was extraordinary, you need to understand what leptocephali are. They are the larval form of eels. Every eel species begins life as one of these things, a willow leaf-shaped, almost see-through creature drifting through deep ocean currents. In normal species, they measure a few centimeters. The European conger, the largest known eel, produces larvae that fit in the palm of your hand. And the ratio between larva and adult is roughly consistent across the order. So when you find a larva that measures 1.84 meters, the mathematics are unavoidable. You apply the known scaling ratios, and you get a parent organism of approximately 30 meters. That is nearly 100 feet of eel living somewhere in the deep ocean that we have never seen. Brun cataloged the specimen under the provisional name Leptocephalus giganteus and deposited it at the Danish Natural History Museum in Copenhagen, where it remains today one of the most debated specimens in deep-sea ichthyology. His own analysis, published in 1959 in the Galathea Report, a peer-reviewed monograph series, included that 30-meter extrapolation. A second specimen, reportedly measuring approximately 2.1 meters, was said to have been recovered in the 1960s, but the documentation is fragmentary. It appears in Gary Mangiacopra's 1977 Cryptozoological Survey, but has never been independently verified in primary literature. The scientific establishment pushed back. In the 1980s, ichthyologist David Smith at the Smithsonian Institution's National Museum of Natural History reanalyzed giant Leptocephalus specimens and proposed an alternative explanation. His 1989 paper in Copea argued that anomalously large larvae were not juveniles at all. They were degenerate adults, fully grown eels that had undergone a reversal of metamorphosis under environmental stress, a phenomenon called neoteny. If Smith was right, the giant parent hypothesis collapsed. There was no 30-meter eel, just a normal-sized eel that had reverted to larval form. But critics were not satisfied. Richard Ellis, in his 1994 book Monsters of the Sea, pointed to the original histological notes from Brun's specimen. The cellular structure, Ellis argued, was definitively larval tissue, not degenerate adult. The cells were growing, not regressing. And in 1998, a New Zealand marine biologist named Bruce Normandale submitted a report to the Museum of New Zealand Te Papa Tongarewa describing an unidentified eel-like carcass of approximately 4 meters recovered by fishermen off the Kermadec Trench. The specimen was not preserved. The Kermadec Trench, northeast of New Zealand, reaches 10,047 meters, one of the deepest points on Earth, and sits in a biogeographic isolation zone where endemism rates for deep-sea fauna exceed 40%. Here is the critical problem. The places where a giant eel would live are precisely the places we have barely looked. The South Sandwich Trench in the South Atlantic reaches 8,428 meters and remains almost entirely unsampled by trawl nets. A 2016 study using deep-sea baited cameras in the Mariana Trench demonstrated that creatures exceeding 1 meter actively avoided trawl sampling gear. We are not failing to find giant eels because they are not there. We may be failing to find them because our primary sampling method is one they have evolved to escape. And the eel family keeps revealing how little we know about it. A 2020 study in Deep Sea Research Part 1 by researchers at the University of Copenhagen identified 14 previously unknown eel species from larval DNA samples alone. The Deep Search. 2019 expedition led by NOAA sampling along the U.S. Atlantic margin recovered Leptocephalus specimens of species never before described. The European eel migrates roughly 6,000 kilometers to spawn in the Sargasso Sea at depths of 4 to 500 meters. And despite centuries of study, no adult European eel has ever been observed spawning in the wild. As of 2024, no genetic sequence matching Leptocephalus giganteus has been submitted to GenBank. Bruun's specimen, sitting in Copenhagen for nearly a century, has never been subjected to modern DNA analysis. Researchers at the Natural History Museum in London have publicly described this as an oversight worth correcting. The question of what produced that 6-foot larva remains, after almost 100 years, completely open. And if the deep ocean can hide the parent of a larva that size, what else is it hidden? In 1977, a Japanese fishing vessel hauled something to the surface that would trigger an international sensation, and a scientific debate that has never been fully resolved. Number 2. The Zuiyo Maru carcass. On April 25, 1977, the Japanese trawler Zuiyo Maru, operated by Teiyo Fishery Company, was fishing approximately 50 kilometers east of Christchurch, New Zealand. The nets were working at around 300 meters depth. When the crew hauled them up, its tangled in the mesh was a carcass unlike anything they had seen. It measured approximately 10 meters, 32 feet in total length. It weighed an estimated 1,800 kilograms, nearly 2 tons of decaying flesh. And its shape was wrong. Assistant production manager Michihiko Yano was the first to document it. He made detailed sketches. He took multiple photographs from several angles. What he recorded was a creature with a small head set on a long, narrow, flexible neck measuring roughly 1.5 meters. The body was broad. 4 large flipper-like appendages extended from it, bilaterally symmetrical, distinct, and structured. The tail tapered. The overall proportions were inconsistent with any known large fish, but they were strikingly consistent with popular scientific illustrations of plesiosaurs, submarine reptiles that went extinct 66 million years ago. The crew faced a practical decision. The carcass was decomposing rapidly. The smell was overwhelming, described in Yano's original log as smelling like dead shark. If it contaminated the fish catch, the entire haul would be worthless. So the captain ordered it dropped back overboard. But Yano, to his enormous credit, collected tissue samples before it went. A small quantity of fin ray fibers. Those samples, and his photographs, were all that would survive. When the Zuiyo Maru returned to port in Yokohama, the photographs were published in Japanese newspapers. The reaction was immediate and global. The Japanese government commissioned a scientific review. The Taiyo Fishery Company, a fishing corporation, issued a commemorative postage stamp depicting the creature based on Yano's sketches. Japan's National Science Museum convened a panel that included ichthyologist Fujiro Yasuda and paleontologist Yoshinori Imaizumi. Imaizumi examined the evidence and made a statement that ricocheted through the international press. The creature, he said, was clearly not a fish. He suggested it might be a marine reptile. Then the biochemistry came in. Shigeru Kimura of the Prefectural University of Fisheries analyzed the fin ray fibers Yano had collected. His results, published in September 1977, were definitive in one direction. The protein structure, specifically the ratio of hydroxyproline in the collagen, matched elasmobranch tissue. Shark, not reptile. Subsequent analysis by New Zealand scientists, including ichthyologist G.R. Forster, proposed a specific candidate, a decomposed basking shark. Basking sharks reach up to 12 meters. When they decompose, the large gill basket and outer skin are the first structures to detach. What remains is the skull and vertebral column, which produce a profile that looks extraordinarily like a long-necked creature with a small head. This is not speculation. It is a documented phenomenon. The Stronsay beast of 1808, a famous sea monster carcass washed up in Scotland, was later identified through the same mechanism, and the smell. Yano's own log noted the carcass smelled like dead shark. Elasmobranchs store urea in their tissues. When they decompose, they produce a powerful, distinctive ammonia odor that is essentially unmistakable to anyone who has encountered it. Tadayoshi Sasaki, a Japanese biochemist, I conducted additional protein analysis in 1978 and concluded with 95% confidence that the tissue was elasmo branch. For most scientists, the case was closed, but not for everyone. Cryptozoologist Gary Mangiapane published a detailed rebuttal arguing the flipper dimensions were inconsistent with pectoral fin placement in any known shark. Kathy Hollis of the Smithsonian noted the posterior appendages were more geometrically regular than typical decomposed shark remains, not proof of anything, but a detail that did not fit cleanly. The discovery site sits directly above the Hikurangi Trough, a subduction zone reaching 3,000 meters, making the area one of the most geologically active and biologically diverse marine environments in the southern hemisphere. The carcass was never recovered. The primary physical evidence was disposed of at approximately 43 degrees south, 174 degrees east. What survives are Yano's photographs, his tissue samples, and a scientific consensus that is strong but not airtight. A BBC documentary in 2001 used computer modeling to reconstruct the carcass and concluded the shark hypothesis was the most parsimonious explanation, while acknowledging it could not be proven without the original specimen. The Zuiyo Maru case is a lesson in how decomposition can transform the familiar into the apparently impossible. But New Zealand's waters hold something older than a decomposing shark, a tradition of deep water creatures that predates European contact by centuries, and that the country's own legal system has been forced to take seriously. Number 3, the Taniwha. The word Taniwha, pronounced roughly Taniwha, appears in the oral traditions of every major iwi across Aotearoa, New Zealand. It translates loosely as water monster or guardian spirit of water. But that translation flattens something far more complex. Taniwha are not uniformly malevolent. Many are described as kaitiaki, guardians of specific bodies of water. In some iwi traditions, a Taniwha is the deified ancestor of a particular hapu, a subtribe. The creature is woven into genealogy, governance, and geography simultaneously. The concept predates European contact entirely. The earliest written records appear in missionary journals from the 1810s and 1830s, including those of Anglican Reverend William Yate, published in 1835. Who documented Taniwha accounts from Northland iwi without editorial comment. But the oral tradition stretches far deeper. Linguistic analysis by Te Ahukaramu. Charles Royal and colleagues has traced the root Teni to Proto-Polynesian cognates appearing in Tongan, Samoan, and Hawaiian traditions, suggesting the concept predates the settlement of New Zealand itself roughly 700 years ago. What makes Taniwha accounts remarkable from a zoological perspective is their consistency. Ngati Porou on the east coast of the North Island, Ngai Tahu in the South Island, and Wanganui Iwi in the interior, communities separated by hundreds of kilometers with distinct oral transmission lineages, describe deep-sea Taniwha in overlapping morphological terms. Extreme length, smooth skin, the capacity to generate whirlpools. Anthropologist Anne Salmond of the University of Auckland has studied these traditions extensively and argued in her 2017 book Tears of Rangi that such accounts encode sophisticated observational knowledge of marine ecosystems rather than representing purely supernatural narrative. In deep ocean traditions specifically, Taniwha are described as inhabiting the Roto o Hine Moana, the belly of the ocean goddess. Researchers have mapped this concept onto the submarine trenches of the Southwest Pacific, the Kermadec Trench at 10,047 meters, and the Tonga Trench at 10,882 meters. The Kurai's tradition of South Island Ngai Tahu specifically references creatures of the Runanga Moana, the Deep Ocean Council, are described as organisms far exceeding surface whale species in both length and darkness of skin, and there is a geographic detail that deserves attention. Folklorist Margaret Orbell documented specific Taniwha associated with deep coastal waters off Three Kings Islands and the Kaikoura Canyon. The Kaikoura Canyon is the only submarine canyon of its depth, 1,900 meters, so close to a populated coastline in the southern hemisphere. It sits within 2 kilometers of shore, and it supports an anomalously rich fauna, including giant squid, sperm whales, and species of deep-sea fish discovered as recently as 2019. Ethnographer Elston Best, whose fieldwork was conducted primarily with Tuho Iwi of the Bay of Plenty between 1895 and 1925, recorded over 40 distinct named Taniwha, each with an associated geographic territory. This is not a vague mythology, it is a taxonomic system. In 2002, the Waitangi Tribunal, New Zealand's Permanent Commission of Inquiry, formally recognized Taniwha in a legal ruling. The case involved a Taniwha named Karutahi. Said to inhabit a wetland at Ngati Naho in Northland, through which a motorway was to be built. The road alignment was ultimately modified to accommodate Maori concerns. As of 2020, the New Zealand Ministry for the Environment lists over 30 active resource consent applications in which Taniwha concerns have been formally entered into the planning process. A 2018 survey by researchers at Massey University found that approximately 58% of Maori respondents considered Taniwha to be real entities, whether physical, spiritual, or both. Professor Rangi Matamua of Massey University has publicly described these traditions not as legends but as knowledge systems, and the Polynesian parallels run wider still. Ethnographer Kenneth Emery of the Bernice Pauahi Bishop Museum documented near-identical descriptions of serpentine abyssal creatures in Cook Islands and Society Islands fishing traditions in his 1947 field notes, traditions separated from New Zealand by thousands of kilometers of open ocean. Te Ao Maori, the Maori worldview, does not draw a firm line between the natural and the supernatural. Anthropologist Michael Riley of the University of Otago has argued this makes Taniwha accounts methodologically difficult to classify using Western frameworks, but filmmaker Barry Barclay put it more sharply. Dismissing Taniwha without engaging with the specificity of their locational and morphological detail, he wrote, constitutes a form of epistemic colonialism. Academic consensus, as of 2024, holds that Taniwha represent a complex intersection of ecological observation, spiritual cosmology, and territorial governance, not simple mythological invention. If the deep waters of the Southwest Pacific harbor creatures preserved in Maori tradition for centuries, then halfway around the world, the archives of a Cold War superpower contain a very different kind of testimony, one wrapped in classified files, state television broadcasts, and the murky intersection of military secrecy and paranormal research. Number 4. The Russian Aquanoids. The term aquanoid, in Russian akvaloid, enters the literature through a single man. Vladimir Ajhaji, a former Soviet Navy officer who held a doctorate in technical sciences. In 1993, following the collapse of the Soviet Union, Ajhaja published a book called Inaya Жизнь, Another Life, in which he claimed access to partially declassified KGB and Navy files accumulated between 1950 and 1980. The files, he said, documented encounters between Soviet military personnel and humanoid entities in deep water. The most detailed account centers not on the ocean, but on Lake Baikal, the world's deepest freshwater lake at 1,642 meters. According to Ajhaja, in 1982, a group of 7 Soviet Navy divers conducting a training exercise encountered humanoid figures approximately 3 meters tall, wearing silver suits at a depth of roughly 50 meters. When the divers attempted to capture one of the figures, they were subjected to a force that propelled them rapidly to the surface. 3 of the 7 reportedly died from barotrauma, the catastrophic tissue damage caused by decompression that rapid. A second researcher, Nikolai Subotin, founder of the Russian UFO research station, published what he described as corroborating testimony in 2003. But Subotin's version added a detail absent from Ajhaja's original. The humanoids had actively deployed an unknown force against the divers. Skeptics noted this escalation across the transmission chain as a hallmark of embellishment rather than independent verification. The most senior official corroboration came in 2000, when former Soviet Navy Admiral Yuri Kviatkovsky, in a television interview on NTV, it confirmed that the Soviet Navy maintained classified files on what he called anomalous underwater contacts. He declined to specify their content. That statement remains the highest-ranking on-record acknowledgement, but the skeptical case is devastating. Russian scientist and SETI researcher Alexander Plaksin, writing in the Russian edition of the Skeptical Inquirer in 2004, traced virtually all aquanoid accounts to a single chain of transmission originating with Ajhaja. No independently sourced primary documents had ever been produced. Every supposedly declassified file was described but never reproduced. no document had been independently obtained through Russia's official declassification request process, established under a 1993 presidential decree. And there is a deeper problem. The Soviet-era KGB disinformation programs, including Operation Infection and related active measures, deliberately seeded false scientific and paranormal claims in both Western and domestic media. It is methodologically impossible to distinguish a genuine anomalous naval report from a planted story designed to confuse intelligence agencies or distract the Soviet public. The Black Sea encounters cited in the literature are particularly problematic. Two accounts, a 1969 incident near the coast of Georgia at 200 meters and a 1975 encounter near Sevastopol at 80 meters, place humanoid biological entities below the Black Sea's anoxic layer. Below approximately 150 meters, the Black Sea is almost entirely devoid of multicellular life. It is one of the most inhospitable environments on the planet for anything with a metabolism. From an evolutionary biology standpoint, no known mechanism would produce bipedal humanoid morphology in a lineage independently adapted to aquatic environments. Marine biologist Andrew David Thaler of Duke University published a public rebuttal making precisely this point. Lauren Coleman of the International Cryptozoology Museum in Portland, Maine, a researcher with a notably low evidentiary bar, classified the aquanoid reports as insufficiently evidence to warrant inclusion in mainstream cryptozoological literature. When the cryptozoologists reject you, you are operating at the extreme edge of anomalous claims. And yet, Lake Baikal is a genuinely strange place. Its depths contain endemic species, including the Baikal oilfish, a transparent deep-water organism with no known close relatives. Chemosynthetic ecosystems were discovered there in the 1990s. The lake has a factual history of biological surprise. The aquanoid accounts may be products of disinformation, embellishment, and a single unreliable transmission chain, but they are layered onto a real environment that continues to defy expectations. The contrast with our next entry could not be sharper. Where the aquanoid reports rely on classified files and anonymous sources, the Tizheruk tradition relies on something far older and far more empirically grounded: the accumulated observations of Inuit hunters who knew their marine environment better than any scientist. Number 5. The Tizheruk. On King Island, Ujivak in Inupiaq, just a remote spur of volcanic rock roughly 90 kilometers from Alaska's Seward Peninsula in the Bering Sea, the residents historically maintained one of the most sophisticated sea ice hunting cultures in the Arctic. They distinguished whale species by spout pattern. They tracked seal populations by breathing hole density. They named currents, mapped ice edge migration routes, and categorized marine fauna with a precision that Western science has only recently begun to document. And among the species they cataloged was one they called the Tizheruk. The creature is described consistently across communities as serpentine, between 7 and 10 meters long. A hook-like or spatulate head, a tail capable of rapid lateral movement, multiple accounts describe it snatching prey from the ice edge, and a hunting behavior that researchers have compared to that of leopard seals in Antarctic environments. This is not a spirit being. It is described as a dangerous animal that occupies specific territories. The earliest written documentation comes from ethnographer Lucien Turner's 1886 report to the Smithsonian Institution's Bureau of American Ethnology. Turner was conducting a systematic ethnographic survey, not collecting curiosity pieces. His informants described the Tizheruk as a real animal. He recorded it alongside equally matter-of-fact observations about tool use, diet, and seasonal migration, placing the creature in the same empirical category as the walrus or the beluga whale. Ethnographer Ernest Birch Jr., whose fieldwork among Inupiaq communities spanned from 1965 to 2000, so noted in his unpublished field notes now held at the Smithsonian Arctic Studies Center that Tizheruk accounts were provided by hunters as practical safety information. They were warnings. Stay away from this stretch of coastline. Do not hunt at this particular ice edge. At least 3 specific geographic locations along the northern Alaska coast were consistently named as Tizheruk territory by informants across different interview sessions separated by years. The locational specificity was stable. It did not drift or expand the way mythological claims tend to. Comparative accounts from St. Lawrence Island, Sivikoq, documented by anthropologist Stephen Jacobson of the Alaska Native Language Center in the 1980s, describe a creature called Palrayuk with almost identical morphological features to the Tizheruk. These communities are separated by approximately 200 kilometers of open water. The Pelryok accounts include a detail absent from King Island traditions. The creature emits a sound described as a low rumbling similar to shifting ice. The Alaska Peninsula, where many accounts originate, sits directly above the Aleutian Trench, the world's second longest trench at approximately 3,400 kilometers, reaching a maximum depth of 7,822 meters. The Bering Sea shelf edge drops rapidly to over 3,000 meters within 300 kilometers of the coastline. A large pelagic predator operating from deep water and making incursions to the ice edge would have both the habitat depth and the geographic proximity to be encountered, exactly where these accounts place it. Chad Arment, in his 2006 book Cryptozoology, Science and Speculation, examined Tizheruk accounts and concluded they were among the more credible North American unknown creature traditions. His reasoning was straightforward. Cross-community consistency. Absence of mythological embellishment. The practical danger warning context. And the observational credibility of the sources, people who could distinguish every known marine species in their environment with precision. Paul LeBlond of the University of British Columbia, who spent 30 years compiling sea serpent reports from the North Pacific, stated in a 2001 paper in the Journal of Scientific Exploration that Alaska coastal accounts showed an unusual degree of morphological consistency, warranting formal scientific attention. Richard Owen himself, the Victorian anatomist who coined the word dinosaur, received multiple independent reports of serpentine creatures in the North Pacific from professional mariners, and noted in correspondence now held at the Natural History Museum in London that repeated descriptions of the same morphology deserved investigation. No physical evidence has ever been recovered. The Bureau of Ocean Energy Management's extensive continental shelf survey, conducted between 2010 and 2015, produced nothing anomalous consistent with the tradition. Emily Hennessy's 2012 master's thesis at the University of Alaska Fairbanks included 8 structured interviews with King Island elders, most relocated to Nome after the island was largely abandoned in 1960, though all 8 informants distinguished the Tizheruk from known species and from supernatural beings. Whatever they were describing something they considered real. On the opposite side of the Pacific, Japanese fishing communities developed their own tradition of something predatory lurking in deep water. But where the Tizheruk is described as a serpent that snatches from the surface, the Japanese creature operates differently. It reaches up from below, and it takes entire ships. Number 6. The Isonade. The name tells you what it does. Isonade, literally shore stroker, or reef stroker, something that strokes, which is to say drags, from the depths along the shore. The tradition comes from the fishing communities of Matsura in Hizen province, modern Nagasaki and Saga prefectures on the island of Kyushu, and from the Goto Islands off Kyushu's western coast. The earliest documented written reference appears in the Buke Myomakusho, an Edo period compilation of military and natural history curiosities dating to approximately 1638 to 1644. The creature is described as an enormous fish. Length estimates in historical texts range from 30 to 100 meters, with a fin armed with hooks or backward-facing barbs. Those barbs could catch on ship hulls, rigging, or human limbs and drag them beneath the surface without warning. No sound, no visible disturbance. Vessels simply disappeared. Folklorist Noriko Ryder of Miami University has written extensively on Japanese supernatural aquatic beings. Her 2003 paper in Asian Folklore Studies makes a critical distinction. The Isonade is systematically different from purely supernatural water creatures like Kappa or Rijin. It is described with zoological specificity, consistent morphology, predictable habitats, specific hunting methods. And crucially, it is never attributed with intelligence or intention. It is portrayed as a large predatory animal acting on instinct. Reader argues this indicates origins in genuine observation rather than supernatural mythology. The geography matters. The Goto Islands fishing grounds border the Okinawa Trough, a back arc basin reaching 2,719 meters, one of the deepest water bodies in the inland seas of East Asia and largely undersurveyed for megafauna. Historical fishing records for Matsura province examined by Osaka University historian Takeshi Moriwaki in a 2010 monograph, contain unexplained vessel losses in the Goto Strait during calm weather across the period 1700 to 1850. No storms, no recorded hazards. Ships simply did not return. There is a physical phenomenon that could explain the silent capsizing from below motif. Internal waves. These are gravity waves that occur not at the ocean surface, but along density boundaries within the water column. In the Okinawa Trough, internal waves have been measured by oceanographers at the University of the Ryukyus, reaching amplitudes of up to 100 meters. They are capable of generating violent surface disturbances without visible warning. Maritime historian Tetsuya Murano of Nagasaki University has compared the Isonade accounts to internal wave events, noting that a vessel swamped by an internal wave would be pulled down suddenly, might silently, exactly as the tradition describes. But there are biological candidates too. Deep-sea sharks of the family Hexanchidae, primitive, slow-moving species, regularly ascend from deep water to shallower coastal waters at night. Researcher Kazunari Yano of the National Research Institute of Far Seas Fisheries documented a 4.5-meter blunt-nose, six-gill shark near the Goto Islands in 1988. The oarfish, the world's longest bony fish at a confirmed 8 meters, with unconfirmed reports exceeding 15, inhabits depths of 200 to 1,000 meters, and has elongated fin ray elements that could conceivably inspire hook fin descriptions. Toriyama Sekien's 1781 illustrated catalog depicted the Isonade with a crescent-shaped tail, smooth, scaleless body, and a prominent recurved dorsal spine features that Bernard Heuvelmans, in his 1968 taxonomy in the wake of the sea serpents, classified under his super eel category. Marine biologist Keiichi Matsuri, retired from Japan's National Museum of Nature and Science, stated in a 2019 public lecture that the Isonade remains unresolved and that the Okinawa Trough's fauna is sufficiently undersampled that large unknown species cannot be ruled out. JAMSTEC has deployed the submersible Shinkai 6500 in the Okinawa Trough since 1991. A 2018 expedition log noted observation of multiple unidentified large-bodied fish at depths below 2,000 meters. They were not recovered for identification. The Japanese Navy's own Oceanographic Research Institute conducted surveys beginning in 1966. A 1971 internal report, partially declassified and available at the Japan Marine Science and Technology Center archive in Yokosuka, noted several unidentified sonar contacts at depths below 1,500 meters consistent with large biological organisms. The silent capsizing motif is not unique to Japan. It appears in Korean imugi, sea serpent traditions, and in Ryukyuan, fishing traditions from Okinawa, cultures sharing overlapping fishing grounds. Whether these parallel accounts represent cultural diffusion or independent observation of the same phenomenon is unresolved. Researchers at Nagasaki University's Department of Marine Science have identified the need for a structured oral history project before the last generation of traditional Goto Islands fishermen passes. Half a world away, in the cold waters between Denmark and Sweden, a creature was pulled from the sea in 1546 that would defeat the best minds in European natural history for nearly 5 centuries. And it still has. Number 7. The Sea Monk. In 1546, fishermen working the Øresund Strait, the narrow channel between Denmark and Sweden, ranging from 4 to 28 kilometers wide and reaching maximum depths of approximately 50 meters, hauled up something they could not identify. The creature was presented at the court of King Christian III of Denmark, and from that moment, it entered the scientific record. The primary source is Conrad Gessner's Historia Animalium, published in 1558. This is not an obscure text. It is considered the foundational work of modern zoology, the most comprehensive natural history produced in the 16th century. Gessner included an engraving and description of the creature based on information sent to him by the French naturalist Pierre Bellon, who had examined a drawing made from the original specimen. Gessner applied his standard systematic methodology. He placed it alongside confirmed species. He regarded the evidence as credible. A second major source is Guillaume Rondelet, the French physician whose Libri de Piscibus Marinis was published in 1554 and 1555. Rondelet claimed to have seen the creature himself. His engraving reproduced in over 200 subsequent natural history works, shows a humanoid form with a tonsured, monk-like head, robe-like scales or skin folds, and vestigial flipper-like limbs. Rondelet treated it as a genuine natural phenomenon. A type of fish, he said, that assumes human form. For nearly 500 years, scientists have tried to identify it. None has fully succeeded. The most influential attempt came from Danish zoologist Japetus Steenstrup in 1855. Steenstrup argued the sea monk was a giant squid, and in doing so, he became the first scientist to formally identify the genus Architeuthis. His reasoning was that the hood of a decomposed squid's mantle could produce a tonsured appearance. The case is partially convincing. But Richard Ellis, in the search for the giant squid, I noted that the historical descriptions include bilateral flipper-like limbs, features incompatible with cephalopod anatomy. A squid does not have flippers. A second hypothesis identifies the creature as an angel shark, Squatina squatina, a dorsally flattened elasmobranch with a blunt, rounded, vaguely humanoid head that was formerly common in the North Sea. The angel shark's pectoral fins, when extended, could appear robe-like. A 2012 National Geographic documentary used computer reconstruction and concluded this was the most consistent identification, but the angel shark reaches a maximum of 2.4 meters, and the tonsured head detail remains unexplained. A third hypothesis, proposed by Christian Christiansson of the University of Iceland in 2003, suggests a hooded seal, the inflatable nasal sac of the male producing a monk cowl effect. No specimen tissue or skeletal remains survive. The creature was reportedly displayed at the Danish court for several days and then either released or disposed of. Pierre Denis de Montfort, in 1801, claimed to have accessed manuscript accounts from Scandinavian fishermen corroborating the Gessner and Rondelet descriptions. But Montfort's manuscripts were lost, and his general reputation for embellishment has cast doubt on his testimony. Charles Paxton of the University of St. Andrews, who has published peer-reviewed statistical analyses of sea monster reports in the Journal of Zoology, cites the sea monk as one of a small number of pre-Linnaean creature reports that defy parsimonious identification with any known species. His preferred position is unresolved. The 1546 date places the encounter at the beginning of the Little Ice Age intensification in northern Europe, a period during which cold-water deep-sea species may have shifted significantly northward into the Øresund, potentially exposing fishermen to species ordinarily confined to deeper North Atlantic waters. Lorraine Daston of the Max Planck Institute for the History of Science cites the sea monk as a paradigm example of the difficulty of applying modern taxonomic standards to pre-scientific natural history accounts. Nearly 500 years of scholarship have produced no consensus. The creature remains formally unidentified in biological literature. And if a creature caught in shallow water nearly 5 centuries ago can resist identification, consider what might inhabit the deepest trenches, where a lineage of cartilaginous fish older than the trees has been quietly evolving for over 400 million years. Number 8, the Abyssal Chimera. Chimeras are among the oldest vertebrates on Earth. Their fossil record extends to the Devonian period, approximately 420 million years ago. They were already ancient when the first trees evolved. They predate the dinosaurs by nearly 200 million years, and they are still here, approximately 52 known species as of the 2023 taxonomic revision, inhabiting the deep ocean under names like ghost shark, ratfish, rabbitfish, and spookfish. They are cartilaginous fish related to, but evolutionarily, distinct from sharks and rays. They possess no swim bladder. Instead, they use large oily livers for buoyancy, which is an adaptation they share with sharks, and one that becomes increasingly important at extreme depth, where neutral buoyancy management is physiologically demanding. Their snouts bear electroreceptive organs, ampullae of Lorenzini, that can detect minute electrical fields from prey. In the total darkness of the abyss, they do not need light. They hunt by sensing the electrical signatures of living tissue. The deepest confirmed chimera habitat is approximately 2,600 meters, the species Hydrolagus trolli, described in 2002. The largest confirmed species, Chimerae lignaria, also described in 2002, reaches approximately 1.5 meters. But there are signals from much deeper. Subbaited camera deployments at 4,500 meters and beyond in multiple Pacific trenches have recorded chimera-like contacts that match no described species. In 2011, a Jamstek submersible expedition in the Izu Ogasawara Trench, maximum depth 9,810 meters, logged an unidentified chimera-form fish reportedly exceeding 2 meters. It was noted without follow-up. In 2016, during NOAA's Deep Discoverer ROV deployments in the Mariana Trench, researchers observed an unidentified pale, large-bodied fish at approximately 6,000 meters that they described in post-dive debriefs as chimeriform. Lonnie Lundstein of the Monterey Bay Aquarium Research Institute stated in a 2019 interview that chimera diversity in hadal zones below 6,000 meters is essentially unexplored, and that the discovery of new large-bodied species in those environments would not be surprising. Then came the DNA. In 2022, a study published in Nature Communications by researchers at the Ocean University of China detected chimera-form DNA sequences in water samples from the Mariana Trench at 8,000 meters, a depth well below any confirmed chimera record. The sequences could not be matched to any species in the Barcode of Life database or GenBank. An independent reanalysis by a team at the University of Hawaii confirmed the sequences were genuine but unmatched. Either a novel species exists at that depth, or the samples were contaminated. The University of Hawaii team considered contamination unlikely. The chimera's closest relatives include species capable of astonishing size. The whale shark reaches 18 meters. The Greenland shark reaches 7.3 meters and lives at least 272 years, based on radiocarbon dating published in Science in 2016. Size extremes in the cartilaginous fish class are demonstrably achievable, and in 2021, the Schmidt Ocean Institute's ROV Sebastian recovered chimera egg cases at 2,200 meters off Costa Rica from two species that could not be matched to any described taxon. Ghost sharks are nearly impossible to study alive. A 2014 attempt by the Monterey Bay Aquarium to maintain a deep-caught Hydrolagus collie resulted in specimen death within 9 hours of capture. Commercial bycatch, the main source of chimera specimens for science, has been systematically underreported in Pacific fisheries for decades, meaning distribution and abundance estimates are substantially wrong. Deep-sea trawling moratoriums implemented between 2006 and 2015 reduced sampling at depth in precisely the regions with potentially the highest chimera endemism. Mackenzie Geringer of the University of Rochester proposed in a 2019 review in Frontiers in Marine Science that hadal food webs were sufficiently complex to support a currently undetected apex consumer. She did not name chimeriforms specifically, but the characteristics fit. A deep-dwelling, electroreceptive, cartilaginous predator from a lineage with 420 million years of adaptive history. As of early 2025, a joint MBARI Jamstek expedition is planned for the Tonga Trench using the Orpheus autonomous underwater vehicle, with a specific objective of documenting large-bodied fauna below 8,000 meters. If something is down there, chimeriform or otherwise, this is the expedition most likely to find it. But while modern science probes the hadal zone with RO-Vice and eDNA, one tradition has been placing a massive creature in the deepest waters for over 3,000 years, and has done so with a consistency that stretches across an entire continent. Number 9. The Makara. The word appears in the Rig Veda. Composed between roughly 1500 and 1200 BCE, it is among the oldest surviving texts of any civilization, and in it, the Makara is referenced as a creature of the deep ocean, the Samudra. That places the tradition's origin at more than 3,000 years ago. By the time of the Matsya Purana, composed around the 2nd or 3rd century CE, the morphology is described in detail. A composite creature. The foreboding of a terrestrial animal, elephant, crocodile, or deer, depending on the source, fused to the hind body of a fish. Multiple limbs. Enormous size. In Vedic cosmology, it serves as the vehicle of Varuna, the god of the ocean and cosmic order. It is associated with the deepest and most powerful waters. This is not a minor figure in the mythology. The Makara is positioned as the supreme creature of the deep. The iconographic evidence is equally ancient. The carved stone gateways at Sanchi, constructed between the 3rd century BCE and the 1st century CE, already depict the composite fish mammal form. The image was established and stable before the 1st century BCE, a time span that suggests it was not invented, but inherited from an even earlier observational tradition. What makes the Makara remarkable is its spread. It appears in Khmer temple architecture at Angkor Wat in the 12th century, in Javanese temple carvings, in Thai, Balinese, and Vietnamese traditions. Art historian Adrian Snodgrass documented this transmission, and Emma Bunker, in a study published in Artibus Asiae, identified at least 11 morphologically distinct regional variants across South and Southeast Asia, all sharing core features: enormous size, aquatic habitat, composite anatomy, association with deep water. The consistency, she wrote, was remarkable given the absence of centralized iconographic authority. Marine biologist Forrest Young of the University of Kerala proposed in 2009 that the composite body description may encode observation of whale sharks, whose spotted pattern, enormous gaping mouth, and filter-feeding behavior could produce elephant-like impressions at the surface. The hypothesis is plausible for coastal encounters, but it is inadequate for traditions that specifically place the Makara in the Patala Samudra, the underworld ocean. Indologist Wendy Doniger has noted that the oceanic underworld in Sanskrit literature is described with extreme darkness, crushing pressure, and absence of sunlight, features that correspond with striking accuracy to Adal zone conditions. The most compelling modern testimony comes from the Bajo people of Sulawesi, the world's most accomplished traditional deep-sea divers who regularly free-dive to 60 or 70 meters. Anthropologist Cynthia Chu of the National University of Singapore documented in a 2003 monograph that the Bajo maintain an active Makara laut tradition. They describe it as a real creature inhabiting the Banda Sea trenches. They name specific trench locations, and they categorize it as natural history, alam, rather than religious narrative. The Banda Sea trench system they identify as Makara territory is among the least surveyed deep-water regions on Earth. A 2020 NOAA assessment found that less than 3% of the Banda Sea floor below 2,000 meters had been directly observed by any research instrument. Paleontologist Darren Naish of the Natural History Museum in London has proposed a different angle entirely. The multi-limbed description, with both flipper-like fins and occasionally claw-bearing forelimbs, resembles the body plan of marine crocodilians like Mechimasaurus and Steniosaurus, which were abundant in the Tethys Sea during the Mesozoic. His fossil exposure hypothesis suggests ancient communities may have incorporated fossil discoveries into their mythological frameworks. Adrienne Mayer's systematic study, The First Fossil Hunters, documented precisely this process in Greek and Native American traditions. But the Makara is not just mythology and not just natural history. It has been integrated into astronomical systems. Associated with the winter solstice, Makar Sankranti, Abris celebrated on January 14th annually across South Asia. Incorporated into Chinese marine mythology from the 2nd century CE onward as Mojie. Robert Beer, in the Handbook of Tibetan Buddhist Symbols, describes the academic consensus. The Makara represents a genuinely ancient form of observational knowledge about ocean life, transmitted across cultures through trade and religious contact, whose naturalistic basis has been overlaid by cosmological elaboration. Coleman and Heer, in The Field Guide to Lake Monsters, Sea Serpents, and Other Mystery Denizens of the Deep, assess the Makara as one of the strongest multi-civilizational convergence arguments in cryptozoological literature. 3,000 years, 11 regional variants, specific trench locations named by living witnesses, and an environment that remains over 97% unobserved. The final entry on this list takes us to the Central Pacific, to Hawaiian traditions of something vast, ink-dark, and coiled at the base of the deepest water on Earth. Number 10. The Auli'i Pea. This creature does not appear in mainstream academic collections of Hawaiian tradition. It occupies the more localized stratum of island-specific oral knowledge, the kind of tradition that is geographically precise, passed between specific communities, and rarely written down. In Polynesian cultures, this is often where the most empirically grounded traditional ecological knowledge lives. Not in the grand cosmological narratives, but in the practical, locational, community-level accounts that tell fishers where to go and where not to. Ito Hawaiian deep-sea cosmology divides the ocean into vertical zones. Kai Uli, dark blue, the surface. Kai Uli Nui, deeper, dark blue. And the abyssal Kaipo, the Night Sea, the Sea of Darkness. This tripartite model was documented by ethnographer Martha Beckwith in Hawaiian Mythology, published in 1940, the foundational academic compilation of Hawaiian oral tradition. The Kai-Po is the domain of creatures not encountered in ordinary fishing. It is the zone where the Auli'i Pea is said to dwell. The geography supports the tradition's plausibility in ways that are almost unsettling. The Hawaiian Emperor Seamount chain sits above one of the most volcanically active hotspots on the planet. Surrounding the islands, ocean depths plunge to 5,000 to 6,000 meters within relatively short distances from shore. Then off the Big Island's Kona coast, the ocean floor drops steeply within 50 kilometers. Folklorist Rubelite Kowena Johnson of the University of Hawaii noted in her 1978 lecture notes that the traditions of abyssal creatures are most extensively preserved in the Puna district of the Big Island and in traditions from Molokai, both locations with access to unusually deep near-shore water. The geographic correlation between deep water access and creature tradition is tight. The creature itself is described as ink dark, darker than the ocean, absorbing rather than reflecting light. That description corresponds to a real phenomenon. In 2020, Alexander Davis and colleagues published a paper in Current Biology documenting superblack pigmentation in deep-sea fish, species that achieve 99.5% light absorption through specialized melanophore arrays. These fish are effectively invisible. They absorb bioluminescent light rather than reflecting it. An organism with that adaptation, encountered by Polynesian voyagers, would appear exactly as the Auli'i Pea is described, darker than darkness. The coiled at the base of trenches motif is not unique to Hawaii. Te Rangi Haroa, Sir Peter Buck, of the Bernice Pauahi Bishop Museum, whose 1938 work, Vikings of the Sunrise, compiled deep-sea traditions from across Polynesia, identified a recurring pan-Polynesian concept, a vast, dark creature dwelling in the deepest ocean, distinct in each island tradition but sharing core features: darkness, coiled or circular form, reactivity to surface disturbance, the Tongan Taufa, the Samoan Taoa Olasami, and the Hawaiian Auli'i Pea. The surface disturbance detail is technically specific. The accounts reference outrigger canoe hulls passing overhead, vessels that generate minimal acoustic signature. If the creature responds to that faint a stimulus, it is reacting to almost nothing. Infrasound generation by large marine creatures is documented in blue whales, which produce calls at 10 to 40 hertz, detectable up to 1,600 kilometers away. Roger Payne of the Ocean Alliance has speculated that a sufficiently large unknown creature at depth could produce or respond to infrasound detectable at the surface. There are unexplained acoustic signals in these waters. The SUST Hawaii Ocean Time Series program, Time Series. As operating station Aloha, approximately 100 kilometers north of Oahu, since 1988, has conducted continuous monitoring in water 4,748 meters deep. Its acoustic instruments have detected unidentified biological sound sources on multiple occasions, documented in data reports but never formally analyzed for biological identity. The Inao, AA-operated hydrophone array in the Pacific, has recorded repeated anomalous biological signals from the deep central Pacific that remain unattributed to any known species. A 2015 survey of native Hawaiian fishers by researchers at the University of Hawaii Oilo found that 34% of respondents who regularly fished in waters deeper than 300 meters reported personal experiences of anomalous disturbance, sudden swells, equipment failures, boat rocking in calm conditions that they attributed to large unknown organisms. The researchers declined to interpret the figure, but noted it was unexpectedly high. And the context of biodiversity in the Central Pacific makes the tradition impossible to dismiss. The Clarion-Clipperton Zone, approximately 2,000 to 4,000 kilometers southeast of Hawaii, has been the subject of biodiversity surveys by MBRI and the Natural History Museum London between 2021 and 2023. Those surveys identified over 5,000 invertebrate species in abyssal plain samples. More than 90% were new to science. The scale of what we do not know about the deep Central Pacific is staggering. No academic monograph, no formal ethnographic study, So, no peer-reviewed biological paper has specifically examined the Auli'i Pea tradition in isolation. Cultural geographer David Stannard of the University of Hawaii has called it exactly the kind of account that deserves systematic investigation rather than automatic dismissal. The creature sits embedded within a tradition of demonstrably accurate ecological observation, a tradition that encoded the stars, the currents, and the behavior of whales, with precision that modern science has spent decades verifying. The question is whether the same precision applies to what those navigators saw, or believe they saw, in the deepest water on Earth. 10 creatures. 10 traditions spanning 6 ocean regions, some backed by specimens, cross-cultural consistency, acoustic anomalies, or unmatched DNA. Some by nothing more than the word of people who knew their ocean better than we ever will. The Hadal Zone has been directly observed across a vanishingly small fraction of its volume. Every tool we have deployed has covered an area equivalent to scanning a few rooms in a building the size of a continent. The skeptical case is strong. Decomposition transforms the familiar into the monstrous, and the absence of physical evidence cannot be explained away. But the giant squid was a myth, until it was not. The coelacanth was extinct for 66 million years. The rate of discovery is accelerating. The deep ocean is the last place on Earth where what we know is dwarfed by what we do not.